Hey everyone, welcome to yet another episode of Coffee Time with Mr. Yin, with your host Mr. Yin, and today we're having coffee. Today in this episode, we're going to be talking about what is interpretable machine learning. Now, you probably think there are two concepts here, right? Number one is what is interpretable. Number two is what is machine learning. So before I jump into any of that, let's not talk about machine learning. Let's not talk about AI algorithms. Let's just take a moment and talk about my experience as a kickboxing fighter. And the reason that's an interesting approach is because machine learning algorithms by itself won't make too much sense unless it's applied on the data. And each data has its own unique personality, has its own unique characteristics. So this interaction with machine and with alive data consists of cycle of extracting information from your prior knowledge, and you look at the data, you collect new information, and you combine them together, and you form something new. That pretty much sums up the essence of my experience in the boxing ring, which is why I think before we jump into anything, let's take a moment and talk about my experience as a fighter. So my journey as a fighter started all the way in China. I've always liked sparring. I hate forms. I think sparring is probably the best thing that you can do if you want to learn something real. And that's what I did. I go on different schools, I challenge people, I spar. And whenever you enter in a boxing ring and trying to spar with people, it doesn't matter what rules you follow. It could be just boxing. You could also add in kicks. If you're following Taekwondo rules or if you're following kickboxing rules, you can of course throw in some wrestling techniques, Brazilian Jiu-Jitsu, things like that. Then you're following MMA rules. We can go by different rules. You can go by different sparring partner. End of the day, we're talking about using my limbs against another person's limbs. And we're using ground skills, we're using our intuition, we're using our ability to assess the distance, and we control that distance between myself and the opponent, and that pretty much governs who wins the sparring or not. So when I enter a ring, I have a certain set of rules that I follow, right? Maybe there's a certain distance. Within that distance, I'm throwing punches. But if you go above that distance, I'm throwing kicks, right? So before I enter the boxing ring, before I talk to this person, before we have an actual contact, I have a set of rules. In statistical terminology, that is called prior. So prior is essentially experience that you collected from whatever things that you do in previous experiments. So now here's the problem, right? It is a big assumption to make to think that, oh yeah, this person that you're fighting right now, you've definitely fought somebody like him before. Well, if you fought enough people, then hopefully that's true, right? Because you only have two hands. How many different punches can you throw, right? So if you have enough sparring experience, then perhaps this person that's brand new, that you have not made contact with, you know a little bit of his move, right? Then that's great. That's great. It sets you up as a higher bar, and maybe you have advantage. However, there are of course situations where you realize, okay, this guy is obviously doing something else. I've not seen his move before. I don't know his rhythm. I don't know what he's gonna punch. Maybe he's gonna be doing something else. So that sort of relationship in machine learning terminology can be considered as you're collecting new data. And this new data that you collect, you're using what you learned to quickly absorb and interpret this data. And hopefully you can make some means, make some inference out of this data. And perhaps the next minute, the next round, when he's doing the same thing or when he's doing a similar thing, you can have a strategy to go against that. That's why I think the essence of interpretable machine learning is actually very much like fighting in a boxing ring. So now you get a little bit of understanding and intuition of where I come from. To make this analogy of fighting somebody in a boxing ring and comparing that with interpretable machine learning. So now let's come back to machine learning. Machine learning is essentially a set of algorithms that I can deploy on a data set and I can make some predictions. For example, in financial service industry, we could have credit card loans, right? A person can come into a bank, he fill out the forms, and we look at the forms, those are the features, those are the information. It pretty much gives us a probabilistic statement of the chance that this guy will default on his credit card next month or not. And then perhaps we can use that to give him a price quote on the kind of loans that he's assigned to, right? Whether it's risky, whether it's less risky, what is the rate? If you default, what is the rate? That sort of thing. It can be pretty much predicted by machine learning algorithms. If you look at computer vision, right, or self-driving car, you take a picture, you take a video of a road condition, right? If there's a person in there, then you want to identify that person's there, and perhaps you stop the car, right? So this sort of prediction-based task is pretty much what we consider a machine learning problem. And you obviously want to look at the data, come up with a set of rules, so that if you have new data, if this thing happens again, you can come up with a decision with as little error as possible. So that's number one. And fortunately, with powerful computer, with parallel computing, with cloud service, and with these deep neural networks serve as our techniques, we can pretty much get the prediction performance to a pretty good level. 98%, 99%, 99.5%, that sort of thing. So that's of course great. But when it comes to decision that's crucial, right? Whether you're trying to assign a patient some sort of medicine, or you're trying to tell this person has cancer or not, that's gonna be an area where high performance is not enough, right? We don't want to assign you some medicine just simply because AI tells us to, right? We want to come up with a reason that from clinical perspective, from biological perspective, from biochemistry perspective, the doctors can look at the results and come up with a set of intuition that help him either assist to make that decision or override some of the old practice. And this is also why I found a little bit frustrated when people ask me, hey, why don't you just build an AI algorithm so you don't have to manage your money? Well, that's not really the goal here, right? I don't want to just build an AI to make money. I want to build an AI and know why it's making money, right? I think that's a more purposeful question to answer instead of just, oh, here's a robot, it makes money and we're done. So unfortunately, a lot of the hedge fund that I've talked to, they're going to a wrong direction right now. Their goal is to build an AI such that there's absolutely zero human intervention. I don't think that's necessarily true. I don't think that's the right direction even. I don't think AI is meant to replace human completely. I think AI is meant to be there to assist us, right? We're the master, they're the servant, right? Let's make sure that relationship is correct. And if you're going to a direction that you think that you can build an AI to completely replace the human, then to make decisions on some business practice, then I think that direction by itself is problematic. It's not problematic in a way that it's passionate. It's not problematic in a way that it's interesting. It's not even problematic in a way that it can be done. It's problematic in a way about innately how you think about the problem, right? It's like that student thinking, oh yeah, I just copy everything on a cheat sheet and I'm done. I can ace this exam. It absolutely does not work that way, right? Cheat sheet by itself, it's a set of rules. What's the difference of that and AI? There's really no difference, right? It's there to help us get somewhere faster, right? But whether you want to go to that direction, that decision comes from people, come from human. AI can help you get there, but whether you should go A or B, that decision comes from human. So in other words, just as same as I look at my cheat sheet and it's like a dictionary, like an index, right? I can probably solve a problem faster. I can't rely on cheat sheet and let the cheat sheet to solve the problem, right? I don't even know if that's possible, right? So if somebody is doing that in the exam, then obviously the student will probably get a low grade. So it's the exact same thing in real life. It's the exact same thing in machine learning, right? The machine learning algorithm, it's there. The AI is there to help you to get somewhere faster, to make this algebra faster, or to come up with a set of rules faster, or make some computation faster, right? But it's not there to replace human. So in other words, based on that perspective, we're having a higher goal right now, right? It's a higher standard and it's something that is in desire. And I think the goal here is to come up with a certain set of practice that can look at the machine learning algorithm and come up with a set of rules or a set of interpretations or visualizations and come up with a list of ideas, a list of quantitative statements to tell us exactly how AI achieve 99% accuracy. And I think that's truly what interpretable machine learning is about. And I think that's going to be the next generation of research that people are getting into, myself included. And I think that's going to be extremely important in terms of establishing that human level understanding. And there's going to be tons of research out there tackling this field if they haven't already, right? A famous technique such as RISE, right? The randomized input sampling for explanation. That essentially when they feed in the data before, they have these randomized generating masks so that they can have sets of pictures that they cover up the important stuff, and then have a set of pictures that cover up the not important stuff. And then they simply compare the results, see which one has higher performance. Now, obviously, if you cover the important one, the performance is going to be bad. Then that implies the things that you covered are important. So that's pretty much what RISE is doing. And then there are some other techniques such as LIME, such as SHAP, right? There are all these fancy techniques that look at the machine learning algorithm. Either you're doing some sort of resampling, or you look at the last layer of your convolution neural network, and you're trying to create a heat map to overlay on the picture so that you can see which area of the picture is color-coded red. Presumably that corresponds to a higher value when it's making predictions to that class. So there are tons of techniques, right? I just gave you 3. I believe in the literature there are much more than that. And right now, these techniques are out there to help you interpret what is the machine learning process and how it's achieving the high performance that it says it achieves. So before we wrap this up, I just want to land on something, right? I think when the Congress people are trying to understand data security problem, the interpretable machine learning can serve as a crucial step to help the audience without the technical background to understand a little bit what is going on in the computer science community, what is going on in the math community, what is going on in the stats community, and help them understand a little bit how these black box algorithms are making its decisions. And I think their conversation could be much more easier if they just have someone doing this on the side to explain to them how does this thing work, right? You don't want to just accuse the CEOs that they're doing wrong. It's not really black and white. You know, it's sort of like a gray area, and depends on different situations, depends on different protocols. And on the website, there are tons of these back-end cache that people are using to create memories. And how these memories are used depends on protocol, depends on different marketing perspectives. And they are created by different business partners from different business entities. So I think there's a hidden network here that is unclear for people that are outside this field. And I believe the interpretable machine learning can serve as a great tool to demystify some of these practices that people are confusing them with. So there you go. I hope you liked today's episode. It's Christmas. Spend some time with family, spend some time with your friends. Hit that subscribe button if you like the video, and I'll see you in the next episode.